Hey everyone, in today's video we're going to check out dynamic configurations, so let's jump right into it. I'd like to start out with an example to have this make sense. So in this case we have a backend server, there's a web server that the user can interact with, and when the user goes to the web server it talks to the backend servers, and because this is a large system we have lots of backend servers, and then we have a database. And in this case, it's a recommendation database. So the backend servers are going to talk to this database, gather a bunch of recommendations, do some business logic on it to figure out which recommendations to show, and then return that to the user. We may want to ask ourselves, well, how many recommendations should I try to query for from my backend server to my database? So you could do something like this. You could define a limit, in this case it's 3, and then when you query, you could pass in that limit. Now we want to control how many recommendations we're querying for at a time because we don't want to overload our database. So what we do is we start with 3. We'll query for 3 recommendations and then figure out of those 3 which ones to show the user. But really we want to query for more than 3. The more recommendations we can look at, the more chances of us showing a good recommendation are to the user. So we'll up that limit to 4. And then when we do it, because it's a code change, we then have to deploy it. And that takes time. If you have hundreds or even thousands of servers, this can take hours or even days, depending on how quickly you can deploy to your test and your pre-prod environments. This ends up being very tedious and time consuming because what we're trying to do is find the appropriate query limit. Now imagine you keep doing that. You keep going from 4 to 5 to 6, and then eventually we get to 9. We're querying for 9 recommendations at a time. But when we do that, we still have to do a deployment, have to do that each time we change it. But when we hit 9, something bad happens. We start overloading the recommendation database because we're querying for so many recommendations now that it gets overloaded and can't handle the request, which in turn kills one of our servers. We look at our alarms and we realize there's an issue. So then we roll back to 8 because that was the last query limit that was acceptable, and then do a deployment which fixes everything. But even that takes time. It took a lot of attempts to figure out the appropriate number of recommendations to query for, and we crashed our server and our database in the process. And this is where dynamic configurations come in handy, because instead of hard coding the value that you want to query for, what you can do is you can store that value in a different data store. You first talk to the configuration database to find the appropriate value to query for, and then query the recommendation database. Now, instead of making a code change and doing a full deployment each time you want to change the query limit, instead, you make one change in your configuration database and the code will change instantly. This is dynamic configuration. It's the process of changing the behavior of what the code is doing at runtime. Let's look at a different example now. So this time we're gonna, instead of figure out how many items to query, we're going to figure out which code path to choose. So right now we have a weather client, and we've talked to our business teams and our partners, and they found a new advanced weather client. So what we could do is just switch immediately over to start using the advanced weather client, but we don't know how it's going to perform at scale or if it's going to work how we expect. So the first option would be to make this one code change, and then everything would start using the new advanced weather client. But if you want to do this with dynamic configurations, you again are going to use some data store, and then we'll ask it if it's enabled. Based on the value in the database, we'll choose whether we use the advanced weather client or the regular weather client. And I did something pretty clever here by passing in the location to the get value. This could be something like a zip code or a country code or city. And what this allows us to do is to turn on the advanced weather client per location. That way, if there's an issue, it's only that one region, it's not the entire system that goes down. This allows us to do a gradual rollout. So I hope you can see some of the benefits of dynamic configurations, but I'd like to point out some of the other ones. The first is that the commit history is going to be much, much cleaner because, referring to our first example, instead of making lots of code changes until we find the right value, we can just make the one code change to talk to the config database. So our commit history is going to be much cleaner. The second is that it's a much safer and faster way to roll out. We can make a new code change, but not actually turn it on until the feature is ready to be enabled. This means that instead of waiting for the update to apply to all of our servers, we can turn it on instantly through our backend. It's also really easy to roll back these types of changes because just like turning them on can be done instantly, turning them off can also be done instantly as well. We don't need to roll back the code change. And then one more is quick experimentation can happen this way. If we don't know the value that something should be, we can experiment and try different ones and then measure performance to see which one's better without making any code changes. This can all be done through the configuration database. Now you might be asking yourself, all right, these things seem amazing. Surely there can't be anything wrong with them, right? Well, the fact is that there's always a trade-off, and one of them is complexity. We now have an additional database to reference in our code. Another downside is the performance. Because we're making another network call, that's additional latency we're adding into our system. Now you can get around this by using some type of cache, but that again is even more complexity because now you have an additional system to manage. The cache does make the performance a lot better, but then there's different trade-offs on how long the cache is going to be valid for. So if you change the value in the configuration database, it might not reflect in the cache right away. And then you could be waiting some time for that value to populate in your system. Locating the true value of a variable can be really hard. I've seen systems have hundreds of these configurations at runtime, and you can never tell by looking at the code what the value of a variable is. It involves going on to the computer, logging into the data store, and then figuring out what the value should be. And finally, there can be extra work to clean up. In that advanced weather client example, we made a code change to reference the configuration database, but then whenever we're fully migrated to that advanced weather client, we should still go back in and clean up the references to the existing weather client. Some people may choose not to do this cleanup step, but then that's leaving dead code hanging, which is never a good thing. If you're thinking that those first two examples are the only way to use them, there are a lot more. I'm just going to list a few here. We saw that we can use it to tune a value. The second example was a feature flag example. You can also use it to schedule a feature launch instead of timing a deployment and trying to get it done exactly at a specific time. We can make the code changes weeks or even months in advance, but then turn it on when we're ready. User preferences are another way to change how the code is behaving at runtime. There's different compliance and legal laws that we can enforce. Failover can happen with dynamic configurations as well. In the event of a catastrophic failure, we can change how our system's operating and where it's running in. We can also use it for A/B testing. And another popular use case is using it as an allow or deny list. So to recap, dynamic configurations are a way to change how your code performs and what it's doing at runtime. And we do this by having some type of configuration database, and our code will reference this configuration database, and then based on the value, we can choose a different code path or assign that value to a variable. And there are trade-offs to consider, both good and bad. So think about those if you're wondering if dynamic configurations make sense for your system and your use case. How have you seen dynamic configurations used in your systems? Let me know in the comments below. and thank you for watching.